The June issue of Gear Technology magazine shows someone's process to develop a solid model from a scanned gear. And I've been doing that for a long time and thought I'd kind of show you what I do if anybody's interested. And I take the gear data from the Coniflex gear data supplied by the customer and create my model, and then correct using a CMM the model to the customer supplied sample. I have to have a supplied sample. I could get away without the gear data because you can, through educated guess, come up with gear data. But I'm going to go through how we do it, and anybody interested can look at the June 2025 Gear Technology magazine and see how it's done there. In the magazine article, they start with a scanned gear and develop their tooth profiles from the scanned model. We start with the Coniflex gear data dimensions from the supplied by the customer, and once you enter this, I'll show you, but you instantly get a gear, and we go on from there. Once you exit out of the technology, you get this tooth form. Actually, you get a bladed gear, but the first thing we're doing is calculating this tooth form here, and then we put the root radius and then generate the pattern, and then we'll cut the gear to the customer's size, and that's already in the that's all entered in the gear data sheet. If there's a part print, then that'll give you all this, and the draft angle on the outside, and there the finished gear. This machine is used for our gear development, and we also can confirm using Gear Pro on our Zeiss. Machine goes through a program to center the part off of the model. We manually set it up and get it started. This is CMM Manager, and that's what have always used for our gear development. Like I say, we've got a Zeiss that we use for verifying finished parts. This works real well. Once the part is set up and verified, we scan the surface just on the gear profiles. We have X, Y, Z calculated coordinates for each one of these points. We move the CMM to the X, Z coordinate, and then inspect to the Y, and then directly take any error that's in the CMM inspection report to modify the gear data. Once we have the CMM verified points, we go back to the gear data sheet and insert corrections at various points directly off of that. Usually we'll go over it 2 or 3 times, and we only use one flank of one tooth because the cut gears are not as accurate as our computer models. And once we get this verified, we take that one tooth and inspect it till points, random points outside the calculated points, we can move those to bring them into our tolerance of, and we have a gear once we go this. It's a couple times. These are some of the parts we've done, from the largest part that we ever did to the smallest. Contact patterns rolled on these, and they are normally what we look for. These are a few of the electrodes that we've made over the years and made dies for.